Okay, so I'm going to do a speed test for Python and race it against Java. Now, a while ago, I made a Java Mandelbrot set program that drew the Mandelbrot set. This is quite computationally expensive because the Mandelbrot set involves complex calculations. There's a square root calculation in there, and it does this calculation for each pixel. And also there's a loop going on, which is measuring orbits around the pixel. So I think it's quite a good test to gauge how fast Python is. So we'll write the same program in Python and Java. What this program is going to do is render the Mandelbrot set and then gradually zoom in on it to a point. And we'll have so many frames of animation going on in the two programs, and we'll race them against each other just to gauge how fast Python is. So let's get straight into it. So I start by downloading a library, graphics.py, and I make a simple loop and I loop through, and if x is greater than y in the screen coordinates, I paint a pixel white, otherwise I paint the pixel black. This turned out to be way too slow. There's no way this was going to do the Mandelbrot set, because just painting pixels with a simple calculation was drawing the screen really slowly. Like here you can see the box is just 100 by 100 pixels and the rendering is really slow. So I've got to find another way to do this. So next I find Pygame. This is a games development library. You install it with pip and it seems to have graphical functions, so I'm going to give this a try. I build a basic Pygame program to do the same as what the previous graphics.py program did. Okay, so here's the program I've come up with. So first I'm importing Pygame, and then I've got a function get pixel color for x and y coordinate. Now that function now is returning red, green and blue values. For now it's just saying if x is greater than y, return 255, 255, 255, which is going to be full red, green and blue, so that's white. If x is not greater than y, return 255 for red, so that's full red, no green and no blue, so that's red. And then in here I've defined the width and the height, and I'm saying Pygame init and Pygame display set caption minimal program screen. This is in Pygame. I got this code from the net, but this is how we create a window, and then this is us painting the pixels of the window. So for each value in y from 0 to height, within that for each value in x from 0 to width, we're drawing a rectangle one by one dimension, and we're drawing it in the color that comes from the get pixel color method. And then this loop here is running true, and then while we're getting an event from the Pygame, and if that event is not quit, which is closing the window, if we're continuing in the while loop. If it is quit, we're running false. So this is a basic program to draw pixels on the screen. When we run it, it takes a couple of seconds, and then there we have that. So now I'm going to modify this program to do the Mandelbrot set. I'm literally going to cut and paste the code from the Java Mandelbrot into the get pixel, and then we'll see if we can make a comparison between how quickly it runs in Python and how quickly it runs in Java. So let's do that. So we'll lift the code straight out the Java and port it line by line to Python. Okay, so here's my Python program now. This is pretty much the same, except I've got the same. The Mandelbrot set, if you remember from the other video, is made out of real and imaginary numbers. So I've got the parameters for this R step and I step. But let's not worry, in this let's not worry for now about how the Mandelbrot works. Just know that in this loop here, I've taken the Mandelbrot set calculation and I've defined it to come out of the get pixel color. The where in the Mandelbrot set that we're looking on the screen is defined by these parameters r start, I start, r end and I end. So if we modify those, we should have another look at the other areas of the set. Now I've got no idea if this is going to work. I doubt it will work first time, but let's have a go. Okay, we've got an error. Now it may take some time to fix these errors. This error is about R step is not defined. Now I've calculated that here. R step is not defined. It's not defined in this context. I think I just need to define it as so that it's in the scope. R step and I step. If I have to change more, I'll go off and do it. Okay. Right, okay, so it's not working, but it's doing something. So I'll work out what's wrong with this and then get back to you. Okay, I'm not sure if it's the only problem, but the R step and I step has to run before we actually don't really want to do it. We only want to do it once before running through the X and Y, and I might actually take this code and put it into this loop directly to save us running that again and again. But when we had this defined outside as 0 and then we were calculating it down here, when we were going into this method we were referring back, so we weren't, maybe I needed to do something like self dot R step equals that, but we were looking at the variable here which was defined as 0 as opposed to the redefined version there. So I just ran it, but I lost patience because it was taking too long with the console. I think this is now coming up with something better, so let's see how long it takes. There, Mandelbrot set, not bad. So what I want to do is I want to go to the Java program and pick a nice bit of the Mandelbrot set that we can zoom into, and then I want to race the two programs side by side, zooming into that place. So let's see if I can do that. Okay, so I want to give Python every opportunity to beat Java if it can do. Therefore, what I've done here is I've taken this R step and I step out of the loop. I really didn't want extra code to be running in that loop. And in order to access the variable, I've had to say global R step. So I think what this is saying, when we define a variable in Python, it just springs into existence. So I think what I'm saying here is I want global R step, and global R step is defined there, and the same for I step. And then this is defined here to be this value, and when it's used in this function it's still this value. So what was happening a moment ago was that I was defining it here, but I was defining it as a local variable, and then when it was used in this method it was actually using the global variable, so it's getting 0. So that's what global appears to do. So now let's have a look at racing Java with Python. Okay, so I'm now looking at the Java program that has, we can navigate through this with the mouse, and also we have this reduced quality thing when it's rendering, and then it finally renders a high quality image. Okay, so what I want to do to race the Java and the Python is I want to render a high quality image and then zoom in to a particular point, and we'll make the point the same in the two programs. When the high quality image is rendered, we'll then zoom in some more, and we'll see if we can race the two programs against each other. So I'll make the change to the Java program first, and then I'll try and do the same with the Python program, and then we'll run them against each other. Okay, so we've got the Java program nicely scrolling into a part of the Mandelbrot set. So that we know it's finished, I'm going to make it so that it shuts the window down once it's drawn the 100th image. And then I'll do the same to the Python program, and we'll see which program finishes first. So that's outside the anim step, so all I need to do is outside this loop is system out print system exit 0. So that's the final racing Mandelbrot Java program. So it's going to draw 100 frames, rendering the Mandelbrot set completely each time. I'll make the equivalent program work in Python, and then we'll race them against each other. I will actually set the resolution of the screen to be the same for both programs. Obviously, that the higher the resolution, the harder it's going to be. Okay, so let's we'll just decide on the screen resolution, and let's say the resolution can be 800 by 800, and I'll use the same resolution in Python. So now let's make the changes to the Python program. Okay, so that seemed to be not too difficult a change. It's the Python program, but I'm not sure how it's going to look. So all I had to do was change the resolution to be the same as the Java program, 800 by 800. Then I'm accessing these rstart, rend, istart and iend, which is the extents of the image on the screen in the complex number plane for the Mandelbrot set. We're messing with those values to do the loop, the zoom. So I just needed to put in this anim step. I think I've done it. Let's see. Syntax error, global rstart. rstart is used prior to global definition. Okay, fine. I've used it in the rstep method. So I guess a sensible place would be to define the globals at the top of the method. So I'll do that for all of the globals. So let's go. Okay, well, unless I've done something wrong in Python, I think I know which is going to win out of Python and Java. Okay, so this race is proving to be a bit of a disaster because the Java is just absolutely thrashing the Python. I expected Java to win, but I didn't imagine by how much it was going to win. So I think to finish off, I'm just going to time how long it takes for the full render of the Mandelbrot set in Java and Python, and let's have a look. Okay, so in the Python program, I'm going to time the time it makes to call the function. I'm also going to change the Mandelbrot function to use math.max instead of the square root, so we're not doing Pythagoras. So if you watch the video on the Mandelbrot set is all about being bounded within a certain region. We were using Pythagoras to measure the distance of an orbit from the center point. If I just do math.max, then instead of the region being bounded by a circle, the region's bounded by a square, so it still works. It should just speed things up a bit. So we ran the function in 3.73 seconds. Now I'm actually not going to call the rectangle draw. I'm just going to modify this so that it just does the calculation. So now we'll just run the Mandelbrot set without even rendering it, and I've already got the display update outside of the timed function. So we'll just get a value for, so to run the Mandelbrot set and plot the pixel took 3.73 seconds. To just run the Mandelbrot set and not even plot the pixel was 2.49 seconds. So let's just make a note of those, modify the Java program and see how quickly Java does it. Okay, let's now the Java one, I am doing the square root function. I am drawing the pixels. I'm even doing repaint after, so there's really no excuse for Python to lose for Java here. So with Python we had 3.73 seconds to draw the pixels and 2.49 to just do the Mandelbrot calculation. Here Java does it in 0.13 seconds to do the calculation, draw the pixels and repaint the screen. I'm a bit surprised, I must say. Java's absolutely thrashed Python there. I thought that I knew that Python was slower than Java, but I had no idea it was to that extent. Am I wrong about this? If I'm wrong, let me know in the comments, but to my investigation of Python versus Java speed test shows that Java has absolutely thrashed it. And I mean, what can be wrong with this code? Okay, so I'm going to go on investigating Python. If I just return the grayscale from this function, so if distance is greater than 2, return grayscale. So I'm not even constructing this 3 number array. Now let's forget all about even Pygame. Let's just run, no, forget about that, it shouldn't make any difference anyway, but let's just run the Mandelbrot function and return just a single value from it. Let me just check, grayscale is not defined. Let's just return return the distance. So I'm just trying to return just any value from the function. So run through the Mandelbrot set and return some value. And we get 2.41 seconds. Let's reduce the maximum iterations down to 15. And we get 1.03. Let's just this is, let's just run through one loop of the function, so we're not even doing any iterations. We don't have the value A. We need to .44. Okay, so I don't know if I'm doing something wrong here, but to run one iteration of the Mandelbrot function in Python, Java can quite considerably beat it by running through 255 iterations, drawing a pixel on screen, and then rendering the image. So Java's absolutely thrashing Python. So that's the result of my speed test. If I'm wrong, if I've done something wrong, if I've configured Python wrong, or if your experience of Python is different, let me know in the comments. But that is what I found. So thanks for watching.